Hello and welcome everyone. My name is Darshit and I'm excited to be hosting this 40-second webinar in our Godrej Storage and Handling Knowledge series titled Maintenance Practices for Lead Acid Traction Batteries of Material Handling Equipment. Before I move on to introduce our esteemed speaker for today, let me just revisit the core purpose of running this knowledge sharing platform that is built specifically for intralogistics domain. I would say it is a Godrej way of giving back the knowledge that we have gathered in the past 6 decades now to society and the industry. I'm happy to say that the response to our platform has been overwhelmingly positive and has been a great encouragement for us to continue this initiative. And we are at the fourth year of this series. Coming to the topic, in an ever evolving industrial landscape, as businesses strive for greater efficiency, sustainability, and productivity, the choices of energy sources and technologies is crucial. And when it comes to material handling, lead acid traction batteries are the backbone of efficient material handling. Keeping this in mind, it is crucial that we explore possibilities of maximizing our battery life through correct charging procedures, understanding the significance of maintaining optimal electrolyte levels, routines for identifying and preventing potential issues through cleaning and inspection, insights into temperature control for optimal battery performance, and crucial safety protocols for safe battery handling and operations. In today's webinar titled Maintenance Practices for Lead Acid Traction Batteries of Material Handling Equipment, with the help of our esteemed speaker, Mr. Srijesh P. Gopal, we delve the into the often overlooked yet paramount maintenance techniques, discussing everything from charging procedures to temperature control and safety protocols. So, whether you are a seasoned professional in the industry or someone looking to stay ahead of the curve, this webinar promises to provide valuable insights and knowledge you won't want to miss. Today, we have distinguished expert in the field of energy and technology, Mr. Srijesh P. Gopal, who will be shedding light on a topic of utmost importance in our industry. Mr. Shijesh brings a wealth of experience and knowledge with over 17 plus years of expertise in industrial services, particularly in optimizing battery performance. He currently heads the service operations of Industrial SBU in West, covering the states of Maharashtra, Goa, Gujarat, Madhya Pradesh, Chhattisgarh, and Rajasthan region at Exide Industries. His track record at Exide Industries reflects a commitment to enhance industrial service efficiency and reliability. His insights have been instrumental in shaping the future of clean energy and sustainable practices in our industry. We are privileged to have Mr. Shijesh P. Gopal as our speaker today, and I'm sure you'll find his presentation enlightening and informative. So, before I move on, I would request everyone to put in their questions in the chat box on the top right of your screen. We shall try to answer them straight away or towards the end of the session. Please do not forget to write your name in the box above the Q&A section. That will help us to get back to you after the webinar in case we miss your question. We hope that by the end of this webinar, you will have a better understanding of maintenance practices of lead acid traction batteries being used in material handling equipment. So, without further ado, I request Mr. Shijesh to take over and wish everyone has an insightful session. Over to you, Mr. Shijesh. Welcome.
Thank you, Darshit. Thank you for the lovely introduction. A very good afternoon to the entire team and a warm welcome to this seminar. So today we will learn a little bit about the traction batteries. I will start with the application and then we will learn a bit about the construction, the technology of lead acid batteries, and finally as Darshit explained, what needs to be done to make it provide a better service life and reliability, the maintenance practices and the best maintenance practices that we recommend as an OEM designer and manufacturer of lead acid batteries. So uh, So we will start with storage battery technology and its maintenance practices of lead acid battery and mainly we will be covering through this session the application, the basic technology of lead acid battery, some product knowledge about the product range, the maintenance practices, the troubleshooting, and the troubleshooting also includes the failure modes that can happen to the traction batteries in the motive power, the new developments, and finally you're over to the crowd for the question and answer session. So, what is lead acid battery? Basically, any battery by design, batteries are designed to perform backup during power outages, or to provide power solutions where there are no, incoming EB power or any other source of power. So, lead acid batteries by design, it can be classified as cells with free electrolyte. These are called conventional or flooded batteries, and the cells with immobilized electrolyte, which are called valve regulated lead acid battery. These are sealed maintenance free batteries. Now, where do we use these batteries when it comes to the application study? As I said earlier, either due to sudden disruption of AC mains power in a standby application, for example, in a power plant, or in a bank, or in a ATM service, or in any other IT industry where backup power is necessary all the time to keep the servers running and the main components running. Okay, or due to complete unavailability of mains power during its storage as in portable condition. So one example of it is the motive powers, backup used in traction batteries. And another example of the second variant could be like villages where there are no EB connections. Extremely remote villages. There are villages which are run completely by solar power. So solar power, once the power is generated, it is stored in lead acid batteries and then used as and when required by the people whenever there is a requirement. So these are some examples, and these examples and these applications takes us further to defining two regimes of application. Further it can be classified on based of application. One is the standby application and one is the cyclic application. When I talk about standby application batteries are designed and manufactured such that they are manufactured and designed in such a way that they are able to store the power and give the power as and when there is a power breakdown. So like UPS, inverters, telephone exchanges, power stations, all these industries are where there is a continuous supply of power. But however, when the external power supply is disrupted on running, and hence the backup power comes into force through the UPS or inverters. So when you talk about cyclic application, cyclic application, okay, cell phones, it's a different example of a lithium ion battery. But let us talk about cyclic application like toys, forklifts, electric vehicles, solar photovoltaics. These are all areas where the batteries charge and discharge every time. For example, the forklift itself, after 8 hours or 12 hours of operation, it is put back to charge. So one entire day, the battery goes on a discharge mode. Then in the night, it gets charged again, and in the second day, it gets discharged again. Such a kind of application where charge discharge happens subsequently is called cyclic application. So standby application is one where we have to give power as and when required, and cyclic application is where we have to provide power every day on a cyclic basis. Now, depending upon this, applications, and another classification of lead acid batteries are they are mainly classified on the basis of construction of their positive plate. Now there are three types of positive plate: flat plate, tubular plate, and planted plate. Okay, so based upon this, they are the batteries are classified as flat pasted batteries normally have the positive plate as flat, and tubular batteries have tubular positive plates, and planted batteries have a plate called planted, which is very different from any of the constructions there. This is a very unique product and mainly used in power plants for high load capacity and prolonged and high rate of discharge backup applications are required. That we are using these kind of planted batteries. And this is a niche product, and the Exide is the only manufacturer in India or in Asia for this kind of batteries. And another type is the VRLA batteries. All the VRLA batteries comes with only flat pasted positive plates. So Having gone through these two classifications, we will quickly go through what are the application types. So cyclic backup, counterweight, and as far as traction batteries are concerned, we normally use the second type of application that we described, that is the cyclic type of application, cyclic type of backup, everyday charge and discharge type of backup. So for this, we have a cyclic backup, we have counterweight, and a cyclic backup running without load, running with load, and lifting the load. So these are the main functions of forklift. The forklift runs with load, without a load, idle running, and the forklift runs with a load, and then the forklift is also lifting a load. So we have three different current variants here. Running without load is the minimum discharge rate. Running with load is the medium discharge rate, and while lifting a load, this is the maximum discharge rate. So the battery that we design should withstand all these three variable load applications whenever they are subjected to any external load. And since the counterweight, the battery also has another application in forklift, that it also acts as a counterweight to keep the entire system in equilibrium. So electrical application as well as a mechanical advantage of acting as a counterweight in forklift. Now, coming together with the application and technology, we can classify them as light application, normal application, and heavy application. Now, the light application includes the standard lead acid batteries and the lead acid battery with extended service interval and maintenance free batteries. So for light applications, we have single shift operation per truck, about 50% of the battery capacity remaining after approximate 5 hours. That means, in a very lightweight application, the battery does not get discharged beyond 50%. For example, if I talk about an 100 Ah battery being fitted to a forklift, and it is operated only for 5 hours at 10% of the discharge current, then only 50 Ah of the battery is extracted. That means the battery is discharged only 50%, and 50% of the battery is still in a charge state or a charge condition. So warming of the battery to approximate 38-degree in ambient surrounding temperature and no interim changes. So this is about light application. When the normal application comes, it will be also a single shift operation battery. But instead of 50%, about 20% of battery capacity will be remaining, which means that 80% of the battery capacity is used. So let us say if it, again, an example of 100 Ah, 80 Ah of the battery is extracted during the single shift operation. And the electrolyte temperature in such batteries may be approximately about 35 degrees Celsius in ambient surrounding temperature, and there can be occasional interim changes also. Now, when we talk about heavy application, this again goes to a multi-shift operation. The condition where the battery is vulnerable to the biggest abuse or most abuse under a heavy application. Okay, approximately 20% of the battery capacity after less than 5 operating hours. Same as sometimes it goes even beyond 20%. I mean, sometimes even 90% is utilized if the battery monitoring system or the battery monitoring system in the forklift is faulty or any other cases. Okay, the electrolyte temperature might even go up to 40 degrees Celsius depending upon double shift operation. And there will be regular changes, interim changes in the specific gravity and voltage and the capacity of the cells. So when I talk about the interim changes, the changes of the property, this refers to the properties of the battery and the performance of the battery as a whole. So when we operate at 50% DOD, the electrolyte level and the specific gravity and the voltage are assumed to be more or less stable throughout the entire life cycle of the or service life of the battery. However, when it comes to a normal application and especially to heavy application, the variation of the properties will be much faster over the service life. And during course of time, minor failures are expected to happen if the interim changes are not looked into and taken care of. So the maintenance practices are least applicable in light application, moderately applicable in normal application, and heavy monitoring is required as far as heavy application is concerned, so that we can extract the maximum capacity out of the during the service life of the batteries. So having gone through the application and learning a little bit about what traction batteries are, and classification of the batteries based upon positive plate and applications, let us understand what is the basic technology of a lead acid battery. So uh, when we talk about, I've mainly focused on the traction cells, because of the point of discussion today here is in traction motive power. So this is the a cut open design of a traction cell. And what if you can see that there are two poles, one the positive takeoff terminal post, two terminal posts. One is the positive takeoff terminal post and the negative takeoff terminal post. And then we have a vent plug and a lid, and the group bars and the positive and negative plates assembled inside the container. So we have the polypropylene PP container, and inside the PP container we have this, you can see the negative plates which are marked in orange color. They are assembled in series, and in between the positive and in between them you can see this separators, tubular positive plates, and the positive spines. And there is also a separator in between the positive and negative plate, so that the positive and negative plate does not come directly in contact with each other and get short. So this is the basic construction. And as I earlier said, we have classified the batteries upon three types of plates. One is the positive, flat positive plate, tubular plate, and plantar plate. So this is how a flat positive plate looks like. It is a metal, pure lead grid grid casting in form of a mesh. And in the mesh we have the active material like lead oxide pasted in between the leads, in between the grids. So this such a kind of construction is called flat positive plate. And these plates are very efficient in discharging high rate of current over a small period of time. For example, the car starter batteries, for a millisecond or a second of duration, a high amount of current is drawn. Since these are flat pasted batteries and they come directly in contact with the electrolyte and take part in active chemical reaction, they have the capacity to discharge a very high current over a short duration of time. Coming to the tubular batteries. So in tubular batteries cannot discharge at a high rate, but it can work for a prolonged period of time. So that's why these batteries are used in cyclic applications. Now, tubular positive plate construction is a little bit different from the flat positive plate. As you can see that the positive active material or the lead oxide is stored inside a sac-like gauntlet, which is strengthened with a spine and connected to a positive or negative group bar. So such kind of arrangement allows the positive material to stay inside the gauntlet without any shredding, while in positive plate there is no such cover. And over a period of 2 to 3 years the battery starts losing its capacity by shredding of the positive plate. So, every charge discharge cycle, there is no loss of capacity for this kind of traction batteries. However, towards the end of the service life, these batteries also might lose capacity. The gauntlet might lose its strength, and the shredding might start happening. So, when we talk about a cyclic application, these are the best designed and suited plates, that will support this kind of cyclic application because of the property that it will not shred. And if you ask me why this cannot be used for, starter applications, and why huge currents cannot be drawn from this kind of batteries, the reason being that there is a gauntlet which is covered, which covers the positive active material. Hence, the participation or the active chemical reaction rate is less as compared to the flat pasted batteries. That's why these batteries cannot discharge a very high current over a short duration of time, but this can discharge current for a prolonged duration of time consistently, and get recharged again and do the same activity in the subsequent cycles or different cycles during its entire service life. Hence, these batteries are, we can say that all the traction batteries all over in this world are positive, are having tubular positive plates. The negative plates, however, for any type of battery remains flat pasted. So as I explained you, why cyclic application, this elimination of shredding. Shredding is the one primary cause, which causes loss of capacity in batteries over there towards the end of their service life. So the active material is completely encapsulated in the gauntlet, and shredding of the active material is practically eliminated. And this has a springy characteristic allowing expansion and contraction without hampering the bonding. So the active material bonding is also not broken, and due to the tensile strength and the material properties of the spines and the gauntlet. Now, fundamentally, we all know that lead acid batteries, as there aren't this isn't too much complicated as far as technology is concerned. It is a conventional thing, and this has been going on ever since battery has been invented. The basic equation of the battery remains the same, although we have tried and tested, and there has been a lot of developments in terms of the capacity and requirements of the industry. The alloy elements in the battery has been aligned and changed to meet the current scenario requirements. So, every lead acid battery works on this principle. They have a positive plate, a negative plate, and a separator and an electrolyte. So the life of the battery begins, the life of a battery begins when, when you first charge the battery or pour electrolyte inside the battery and seal the battery. So the life begins from there. So as soon as you pour electrolyte in a freshly constructed new cell, the cell has to be put on to charge, within next 12 hours at least. So in our factory, this is normally done, immediately or within the next 4 hours. So we have, at the positive plate, as I told you, is it is constructed with the lead oxide. We have PbO2, and the PbO2 reacts with H2SO4 during the charge condition. So we have PbO2 plus Pb plus H2SO4 in a fully charged battery. So that's why we say that we measure the voltages across PbO2 and Pb. Pb is the negative plate, and we can see that the voltage should range around somewhere around 2.15 and 2.17 in the open circuit condition. And when we measure what is the state of charge of the battery, we can test the specific gravity of the battery. So the H2SO4 inside the battery will show a specific gravity of 2.80 in a 100% charge condition in a new fully charged battery. So when these batteries are loaded onto a forklift vehicle and allowed to operate under load for some duration of time, or from 8 or 9 hours upon the designed backup of the forklift and the load requirements, what we get on a battery after 8 hours of operation is the battery in a discharge condition. At this point of time, the specific gravity, if it is 50% discharge, it will be somewhere around 1250. If it is 80% discharge, it should be somewhere around 1190 to 1220. So this will be the range. We will discuss that later in detail. So this will be the range, and we have some H2O. So the low specific gravity acid what we have here in H2SO4 has now converted to H2O. So what happens during the discharge cycle is that the PbO2 and Pbe, the SO4 ions are released, and giving potential to the positive and negative plates. Okay, and the chemical energy is converted into electrical energy. The chemical energy stored here in the form of high specific gravity is converted to electrical energy. SO4 ions actively participate in the reaction. They create potential difference between the two plates. And what is left inside the cell after this, all these SO4 ions are extracted, and the entire chemical energy is converted into electrical energy, is we have SO4 ions getting reacted with the lead at the positive plate and and negative plates, and forming a component called PbSO4, which is called lead sulfate, and a low specific gravity electrolyte, which will be in form of water. However, this reaction is irreversible, and when we charge the batteries post discharge, when we charge the positive and negative electrodes, and we charge the batteries again, the PbSO4 tends to break again, and the SO4 ions reacts with H2O and starts forming H2SO4. And at the positive plate and the negative plate, we have again PbO2 and PbO. lead oxide and lead, spongy lead. So this is how, a battery, what a battery does, for the power backup system. It converts the electrical energy into chemical energy, and then it converts the chemical energy, stored chemical energy, back to electrical energy whenever there is a load requirement. So very simple technology, and very widely used, but there are also some disadvantages, or let me say not disadvantages, there are also some things that should be taken care of when this goes into the discharge condition. The PbSO4, calling which we call the lead sulfate, is not a very friendly battery friendly component, because this PbSO4, in due course of time, it gets hardened on the positive and negative plates. And this once this is hardened, it is very difficult to remove this hardened salt from the surface. So this in turn increases the internal resistance and also the capacity of the battery in due course of time. So the first point of maintenance we always tell the customers is that never allow your battery to be in a state of discharge or partial charge for a prolonged duration of time, because this will attract PbSO4, or lead sulfates, and these are very, very harmful for the life and performance of the batteries. So as you can also read from the description, there is a continuous change in the crystal volume and charge and reverse discharge change in the resulting in reversal of the stress of the interface and leading to active material shredding. This can also cause active material shredding also in future. Now, you might be asking questions to yourself or maybe to me later, like, why tubular batteries only in traction batteries? And the answer is, Sienna, there is no active material shredding in tubular batteries, and the spines are deeply embedded. And these batteries can survive in extreme operational conditions like temperature and humidity, and they can run over 1,200 cycle with 80% DOD. One charge discharge is, when a battery is discharged to 80% depth of discharge and recharged again, that is one cycle. So we can have over 1,200 to 1,500 cycle depending upon the type of batteries. Okay, and which means a service life of almost 3 years. Even beyond warranty, we can have a service life of 2 years, and it is extremely resistant to overcharge also. And the tubular batteries have another property that, it can even be recovered from a deep discharge state of condition. So if today your battery is discharged to some due to some condition, operational condition, beyond 80% or even up to 80%, if you don't prolong the period for the recharge, then these batteries can very well be recovered from, a state of deep discharge. While the flat piston batteries, once it goes into a deep discharge state, it is very, very difficult to revive this back. So we always recommend that, the end cutoff voltage setting of the batteries should be designed and maintained properly, and it should be ensured that the batteries does not discharge beyond that point. Okay, there's something about the spine alloy, what imparts the strengths and, strength the active material, and this spine alloy is also 99.99% pure lead. Okay, so but there are some point 1 to point 0.01 to 0.02 or 0.03% also sometimes some impurities are added, like antimony, or to provide corrosion resistance and strength to the spine, because lead itself is a very malleable and ductile metal. So this cannot withstand, if heavy positive active material is to be deposited for higher capacity, then any range or size or thickness of pure lead structure will not support this. So we have to add some impurities, and these advantages of adding the impurities is that this will have very high corrosion resistance and low water loss. So low water loss means loss of electrolyte. So when the active chemical reaction takes place and happens over periods and months, there is always a water loss due to the high temperature or operational condition, or hydrogen loss from the electrolyte. So this is normally compensated by adding DI water. So the rate of water loss will be less. And having learned about the product and its applications, we will just study what the traction family is all about, you know. So mainly the traction battery family are made of two standards. One is the DIN range and the BS range, Bureau of Indian Standards and so HSP Classic is a normal battery used for, you know, normal applications, and Gen X traction batteries are normally used for heavy applications. So HSP, both HSP and Gen X have a BS range of cells as well as a DIN range of cells. Now, the traction batteries, why they are different from, you know, the flat pasted positive batteries are, the flat pasted positive batteries are manufactured at, you know, aceton rating. Okay, which means that, you know, the battery is designed to deliver 10% of, you know, the AH capacity, the power current at the rate of 10% of the AH capacity for a period of 10 hours. So C5 rating also, the traction batteries are made at C5 rating. So coming to the traction battery and the going a little bit further and elaborating further, you know, the BS range of cells have, you know, nomenclature like XPF, IMF, ILF, TLF, and THF. And they provide cells from 58 AH to 841 AH with various ranges, you know, which can be fit into any type of forklifts. So the DIN range again has, you know, a capacity from 120 AH to 1400 AH. And nomenclature, they starts with normally the X and LX. So here it starts with, you know, XV and IL, TL, TH, all these ranges are there. This is how we can identify, you know, whether it is a Gen X battery or, you know, it is a DIN range or is a BS range. So uh, you know, traction batteries are not never tailor made. They are already having standard models for the standard equipments, but also can be custom designs depending upon the space available, voltage, AH requirement of the capacity, and by choosing appropriate cells from the above range. So apart from having standard, you know, composition for the traction batteries, the traction batteries can also be custom made, and according to the, you know, space available and the voltage requirement, the current requirement, we can size the cells and, you know, we can design it array, and, you know, we can fit from any of these range of cells, we can fit the voltage, we fit the cells to the voltage requirement and deliver the battery. So when we talk about Gen X battery, okay, Gen X battery again, you know, in Gen X the BS range has, you know, 42 AH to 1404 AH capacity cells are there. So it's a huge classification as far as, you know, technology and this is concerned. And again, in DIN range, we can say that, you know, we have cells from 100 AH to 1550 AH. So 1550 AH is the maximum biggest cell that can be manufactured for any traction battery. So let us understand, this session was mainly focused on maintenance. However, you know, I wanted to take you, make a very short journey through the product and its application so that, you know, it is easy for us to understand the maintenance practices. So there aren't too many activities involved as far as the maintenance is concerned. Battery maintenance mainly includes recharging the battery. Do not allow the battery to be idle in the discharge condition for a prolonged period of time. Please recharge it immediately as soon as the discharging period is over. Regularly topping up with the water. That means we have to check the electrolyte level regularly. This is very easy to do. If you have a both manually and with an instrument also, this can be done. It's just a visual inspection. And cleaning and washing, it's very important because you, during top up, you know, or during the course of the forklift, with load, without load, during any rough surface, and if the top up has been done, the water levels at the top level, there is likely to be a spillage. And since the spillage is happening of an electrolyte, when this electrolyte dries, an a current path will be formed which will cause leakage current. So again, cleaning and washing at regular intervals are important, and testing of the leakage current is also important. And there are some physical and inspections and checks which has to be periodically done, and some records have to be maintained to analyze the root cause of failure of if any failure occurs in future, even after the maintenance practices. Now, hydrometer, we need only, we don't need a very complicated maintenance team and system or tools and consumables. Very simple hydrometer of V2B type, gravity correction thermometer, one cell testing voltmeter, and some battery grade DM water, petroleum jelly, and battery grade sulfuric acid only if required. So sulfuric acid should never be added as a top up. In fact, it should only be used under the guidance of the OEM whenever, and this can be done only if the battery has to be completely revived, is to be taken all the cells, and electrolyte has to be taken out, and new electrolyte or some repair has to be done, and new electrolyte has to be put in. Then only this will be done. And secondly, only in case of transit, whenever there is loss of electrolyte due to topping up or falling from the truck, or any damage happens and electrolyte is lost, and those cases only sulfuric acid should be added, and it should be done only in consultation with the OEM and strictly in presence of the OEM. So coming to the maintenance practices with these tools and this battery maintenance sequences, we first go to the charging. Okay, so there are different charging profiles. Okay, the recommendations, that the output should be matched with the capacity of the battery. That means basically, when charging is to be adopted, we should have the appropriate kind of charger. And the charger should have different charging profiles. Different charging profile means it should have a CV charging profile, it should have a CC charging profile, or it should have a CV/CC both charging profile. Okay, so CV charging I will explain in detail where CV and CC is required. And the output of the charger should be matched with the capacity of the battery. So which means that if I am charging a 600 Ah battery, the charger should be able to deliver at least 20% of 600, that is at least 120 amperes. It should be able to deliver. If it is not able to deliver anything less, up to even 10%, then the charger will not be able to charge the battery in the next 12 hours or 10 hours, whatever is the recharging time. And the time for the recharging will get prolonged and elevated, and hence, the recharging time will be more than the operational time, which will be resulting in loss. So selection of chargers for the traction batteries based on the capacity is very, very important. And they should be sufficient to charge the battery, and they should be able to deliver the current recommended by the battery manufacturers. Now, different charging profile is that, one is the constant current. Constant current charges, like um, normally at 15 to 80% of the rated AH till 2.4 VPC is achieved. So when I say that, I should charge the current battery with 15% to 18% CC charging till 2.4. 2.4 VPC is 2.40 volt per cell. So normally the traction batteries can be charged up to 2.7, 2.8 volts per cell. Okay, as a matter of fact, the lead acid batteries can be charged even up to 2.99 volt, but it will never go to 3 volt. How much you pump in the AH capacity capacity, the voltage will never go beyond 2.99. So theoretically, that is the maximum that can be achieved. However, in now practical scenario, the traction batteries can be charged even up to 2.75, 2.80 volt during the commissioning. So when I say that, up to 2.4 volt, it should be charged with a CC charger, which means that the current will be constant. The current will be constant, and the voltage will be increasing steadily till 2.4 volt. Now, why 2.4 volt? 2.4 volt is the voltage where the gassing inside the battery happens. So anything charged beyond 2.4 volt, the battery will start emitting hydrogen gas into the atmosphere at a rate much higher than till it achieves a charge voltage of 2.4 VPC. Now, we don't want the hydrogen ions to be lost into the air with hydrogen gas as hydrogen gas, because that's not going to be useful either for the environment or for us. So hydrogen gases, if it goes out of the electrolyte, then we will have to add hydrogen. We'll have to add frequently add DM water to compensate that hydrogen loss. Okay. So, but however, the batteries need to be charged beyond 2.4 to achieve the full age capacity. So, how do we control this? If I continue to charge with a CC charger beyond 2.4, the constant current will continue to allow the hydrogen escape at the same rate. Okay. So, maximum 11 hours in case the battery potential does not reach 2.4 VPC as a protection measure. The phase should minimum last for 30 minutes even as the battery reaches gassing potential. So gassing potential is 2.4 VPC. So this is the I phase, and then comes the U phase, unfold phase. Okay, then we hold at the U 2.4 VPC till the current tapers to 5% of the rated age capacity. So what we are doing here is that, we start with 15 to 18% till we reach 2.4, and then we allow the current to taper down to 5% at 2.4C. So holding at 2.4C, the current profile goes down to 5%. Okay, and together with the one I phase and U phase, it should be a maximum of 11 hours of charging or maybe 10 hours of charging. Okay, then what happens in phase 2 is that once this phase is again, we charge the current change at 5% charge till 2.65 VPC or maximum time 3 to 4 hours. Okay, so after 2.4 is achieved, we reduce the current to 5%, and then we can stabilize the current at 5% to 2.65 volt per maximum, volt per cell maximum. 2.65 to 2.7, anywhere it is okay. This is the stage where the battery is in a state of 100 charge, fully energized with 100% capacity. And if we happen to measure the electrolyte at this point of time, we will get the electrolyte specific gravity as 1.280, which shows that the battery is in a fully charged condition and it is ready to deliver power in the next cycle. Apart from this, there is also a concept called equalizing as far as charging is concerned. Now, why equalizing should come into picture, why it should happen. Now, traction battery is an assembly of cells. We might have some 48 volt system, 24 cells will be there. 48 volts, 96 volt system, 48 cells will be there. Now all these cells are, though they are manufactured during the same process and at the same lines and the same quality checks. However, there are some tolerances of positive plates and negative plates. So these tolerances in due course of time, over a service life of 3 to 4 years, if the charging profile and the discharging patterns and the maintenance practices are not, followed properly, the cell internal resistance will vary and different cells have different capacity. So if a 48 volt system it is there, some cells will be at 1.97 volt, some cells will be at 2.03 volt, some cells will be at 1.9, again some cells will be at 2.05. So this variation, wherever this variation of more than 0.05 volt occurs in any battery in an assembly of cells, there we need to equalize these cells to come to a equal charge. So that what happens is that when you put such a batteries on discharge, the battery with the lowest float voltage will discharge faster and go to the end cutoff and go into a state of deep discharge, while the others than the other cells. And when recharging, this battery which has gone into the deep lowest voltage cell which has gone into deep discharge will take much more time to get recharged than the other cells. However, your charger will cut off the charging voltage as soon as it achieves the total voltage. So in a battery, unequalized charge battery, we have some cells with very high potential of 2.75, 2.80, and some cells with 2.23 and 2.15. Because and those cells in due course of charge discharge time, these cells tend to go weaker and weaker and weaker. And after 6 or 7 months of operation, these cells suddenly loses its capacity and results in the failure of the battery. So in order to avoid all these circumstances and all these outcomes, we recommend this equalizing charges. So the moment we find out that, even after completely charging the battery, the variation in the cell voltages is more than zero point 0.5 or 0.05 or zero point 0.1 volt or zero point 0.2 volt. Okay, we conclude that, uh, you know, that the batteries are unequalizedly charged. So the effect of low voltage, improper setting charging during the life cycle, insufficient charge, cause star carbation, over discharge, and shorten life. Okay, the cause is under potential charge, chances of imbalance among the cells in the bank, resulting in some cells remain undercharged. That's what I just try to explain you. And the reasons are initial differences in cell voltage, difference in cell charge acceptance, and abnormal working condition. So these initial differences later on, accumulate and accumulate and accumulate and give way for a larger failure mode in the future. So to eliminate this initial indifference, we recommend equalizing charge. Now, equalizing charge is normally, once you complete the charge of 5%, you allow the battery to stay at 5% or 6% of constant current for a period of 3 to 4 hours. So when you allow this, and equalizing charge need not be done every day, it can be done on a weekend day, or or let us say, when there is a weekly off, so that only 3 4% 5% of the current goes in. And this 5% of the current, what it will do is that, it will try to balance the cells. It will just try to attract, since all the cells are in series, the current will flow into cells which are starved or deprived or at a lower potential, and then it will try to charge the cells. Since the current is constant, and it will try to charge the cell with the lowest potential difference, the other cells will also, the charges will also not increase. So hence, after when you come back from the weekend holiday, or if you have a 3 4 hours of break and you come back and see, you can see that, the specific, not only the specific gravity, the voltage of the cells have also stabilized, which means that, the battery has been now put into 100% usable capacity. So for the next 1 week or next 1 month, we need not bother about the equalizing charge, unless and until we notice that there is a marked difference in voltages between individual cells. So there is one terminology here called, electrolyte stratification. So electrolyte stratification normally does not happen in motive application or cyclic application. This normally applies in, standby application. So this being a theory, this terminology has just come up. So electrolyte stratification is something like, that the electrolyte inside the cell tends to have, a non-homogeneous kind of behavior. That means if you top up the electrolyte, normally the H2SO4 should mix with the water. But in some cases, in standby applications, the movement of electrolyte, and if it is in a state of constant float, this mixing of the electrolyte does not happen. So you see that, there is a density difference. When you measure the density on the top, there will be more of water. And when you go to the bottom of the electrolyte, insert the hydrometer deep into the bottom of the cell and measure the gravity there, the gravity will be different. It will be more. So this kind of a pattern is called electrolyte stratification. So equalizing charges also helps you mix the batteries. Okay, uh, the water and the electrolyte, the top of water and the electrolyte mixes, and maintains a homogeneity inside the cell. So electrolyte certification, if it happens, the rate of reaction whenever there is a load coming on the cell in most of the times forgets to provide backup, because it does not have a uniform, chemical reaction over its surface area of the plate, or the positive plate and the negative plate. Below part of the positive plate will have rate of more reaction, while the upper part will not have reaction at all, due to the stratification. So this is one terminology I just wanted to explain. And the recommendation of specific gravity, we can measure the state of charge of the battery by just measuring the specific gravity also. So as I earlier said, the fully charged battery will always have specific gravity from 1.280 to 1.290. We call this state of charge 100% SOC, 100% state of charge. And the initial filling specific gravity, when we commission the batteries, we fill the specific gravity from 1.250 to 1.260. Excuse me, please. Sorry about the interruption. Now, um, the specific gravity below which battery should preferably not be discharged is 1.130. So you have been running the, forklift the whole day, and end of the day you come and your forklift gives a message that the battery has lost its capacity, and if you measure the specific gravity, and if it is somewhere around 1.130, that is an alarm. You must put the batteries back to charge again. 1.130 specific gravity means that we nearly have no electrolyte left in the battery, only water. And the positive and active positive and negative plates are having lead sulfates and no more spongy lead. So this is the condition wherein we must immediately put the batteries to charge. So during charging also, we must note that the temperature does not exceed 50 degrees Celsius. The moment the temperature exceeds 50 degrees Celsius, we must stop the charging and allow the battery to cool for some time, and bring the battery temperature back to the ambient temperature, and then we charge it again. Suppose we are charging it at 18%, 20%, and we find that it has achieved 15%. So after the cool down period, we must start with the lessened current, that is somewhere around 15% we should start, so that and the temperature also depends a lot on the environmental condition. If it is extremely hot and humid, the temperature of the cells will also rise. So accordingly, we will have to control the charging current also. Now, state of charge, as I already told you, fully charged 100%, moderately charged, partially charged 75%, and 50%, 1.245, 1.215, and deep discharge is 1.170 or 1.130. So 25%, we should not allow anything to go below 25%. So coming back to, we have learned about recharging, and the importance of recharging, how this should be done, and at what intervals this should be done. And we come out to learn about other maintenance practices. So batteries must be recharged at the end of every shift, and it should not be left to discharge for more than 24 hours. And repeated charging only after light discharges can cause unnecessary wear and should be avoided. So, we normally don't recommend intermediate charging. So, if there is a tea break of 15 minutes, we don't recommend that the forklift be put for a charge for 15 minutes, because that will not add anything to the age value. So such kind of unnecessary charging should be avoided. And the charging room should be designed such that there should be sufficient ventilation, because you are charging again up to 2.65, and what happen 2.40 volt is hydrogen evolution from the battery. And hydrogen is a very highly inflammable gas. It should not be allowed to accommodate inside the room. Hence, the charging room should be sufficiently ventilated and sufficient airflow should be there. It should not be a closed AC environment. And do not the charge the battery at very high current. Okay. So another important thing is that if you charge with high current, the battery will get charged faster. It's not the concept. That concept is not exactly correct, because it has got many other disadvantages like water loss, and and charge retention of the battery will also reduce. If you charge it at moderate and slow current, the charge acceptance will be much higher, and gassing will also not happen. And for charging with a higher rate of current will also increase the temperature, and this in any case should not be allowed to go beyond 50 degree. So the duration of vehicle runtime for a vehicle may be observed for gravity of the cell to fall from 1.32 specific gravity, 1.130 specific gravity. In case the gravity drops every time to 1.130, then this pattern needs to be analyzed, and probably the cell is giving a sign of failure, and the OEM should be informed, and a team from the OEM should come and inspect the batteries and analyze the root cause and do the necessary action to correct this. Going further on maintenance, the containers and lids in the battery room should be clean, because the battery room itself will be a very corrosive environment due to the evolution of hydrogen gas and electrolytes. And from the battery surface, acid stains should be cleaned. A regular cleaning of the terminal should be done. But while cleaning, please ensure that the positive and negative material are not brought in contact by any external tool or equipment or even with a hand. So the person who doing the cleaning work should not have, any type of metals on his hand, like, gold rings or kada, or bracelets or anything like this on his hand. And he should be wearing an insulative glove, and with a dry cloth he should be doing this cleaning. And never use any kind of solvent, soap, oil, detergent or anything on the product. Just clean it with plain cloth. The specific gravity, voltage and temperature of your reference cells should be measured periodically and noted down. And electrolyte in all levels should be checked periodically during every charge discharge cycle. And ambient temperature should be recorded. That is for to assess the temperature of the battery. And equalizing charge should be applied. I normally recommend the customers to do it at least once in a week, and if they can't do it once in a week, they must do it once in a month. And use good quality hydrometer, thermometer. Tighten all wiring connection to proper specification. Ensure that the contact terminal is intact and gone. So all the battery cables and their connection should be checked regularly. And if any defective or loose connectors are found, they should be that should be informed to the OEM and repeated immediately, repaired immediately. So having gone through the maintenance practices, there are some do's and don'ts also for the traction battery, which it is very mandatory to follow. So the electrolyte level before charging, and check the electrolyte level before charging and top it up with proper battery grade water. So this is the first thing that you should be doing for batteries which have not been refilled, after a period of 1 or 2 months. Before charging, the lid must be opened and the electrolyte level must be checked. If there is some deficiency in the electrolyte, remember, no sulfuric acid, but only battery grade DM water should be added and topped up, and then the battery should be put on charging. After charging, if you put electrolyte, then again, the concept of electrolyte stratification will come into force. Okay, and you might not get appropriate capacity from that cell. So match the battery to the correct charger and have it checked periodically to avoid improper charging. Recharge the battery daily unless the battery has been lightly discharged under utilization. If the battery is used only 20% and 80% capacity is remaining, no need to recharge it. You can recharge it, but there is no necessity to recharge. But however, if it discharged below 50%, mandatorily it has to be recharged. Then periodical cleaning, equalizing charge, and keep the battery top tray clean and dry all the time. Intercell connectors and especially for the bolt-on batteries, please check the bolt-on connector tightness periodically, and ensure that the insulating shrouds on the cell connectors are in position, because if these are not in position, then any external object falling on the battery might short the positive and negative plate and cause an explosion. Remember, the battery is a DC power source. It's not an AC power source. The entire energy is stored in the battery in form of a DC. So shorting of any positive and negative plate will be much more dangerous, and the results will be much more significantly dangerous than shorting of a AC positive and negative terminal. So we must take extreme care of safety and insulation. The condition of the charging socket plug also needs to be checked, from the safety point of view. And regular readings of specific gravity, voltage and temperature should be recorded during every charge discharge cycle. So if the batteries are to be stored in charge condition, then the main cables must be disconnected, and we should give freshening charges to the battery at least once in a month. So for any reason, if the forklift is going to be idle for a month or 2 month or 3 month, then we should remove the battery from the forklift, disconnect the positive, and isolate the battery, charge the battery, and then isolate the battery and keep it safe in a dry place. And if it is not getting, if it is getting stored beyond a month, then we should give a freshening charge one time intermittently in a month. So again, do's and don'ts. Do's, the battery charging room should be well ventilated with an exhaust system to prevent the accumulation of hydrogen gas, as well as to provide proper cooling to the battery and avoid overheating. Some don'ts, uh, never leave the battery discharged beyond 24 hours. Never top up the cells with acid. If any such situation comes wherein the cells have to be topped up with acid, that should be referred to the OEM, and only the OEM person should come and do carry out this activity. So do not maintain the electrolyte level above the separator level. This may cause acid spill out. So a moderate level electrolyte should be should be done. If the electrolyte level is too high in the cell, this will also cause spillage during movement of the forklift. Another very important thing, never use any other water than TM water, because the tap water has a huge content of impurity. And if this tap water is poured inside an electrolyte, immediate chemical reactions might happen. And it can even lead to conditions like cell burst or blast. Okay, and this will also completely damage the positive and the negative plates and erode the battery and cause failure in a very short span of time. So overcharging of the battery, similarly, that's one thing that should be really taken care of. Once the battery reaches the cutoff voltage, the charger should be efficient enough to cut off the charging and then allow the battery to cool down. So battery should be kept away from any naked flames, sparks, or any welding work or any civil work. And remember, battery is a source of power, and any battery is always in an energized state, and it's a light bomb. Any external parts falling on the surface of the battery and shortening the positive and negative plates, or any kind of heat or spark or anything which causes ignition, will cause a fire or burst from the battery. So never use non-insulated tools while working with the batteries. And as I already told you, wrist chains, loose metal bands, rings, all these things must be removed when you're doing battery maintenance. Now, metal vessels and jugs should not be used to store battery, water or acid. It should always be either stainless steel or preferably plastic, high grade plastic. So the temperature of the cell is also very important. It should not be allowed to go beyond 50 degree. So these are the main do's and don'ts. And let us find, the common failure modes in a battery. What are the service issues that comes in a battery? Now, the most common service issues, over the years of my experience and my team's experience, the common failure modes that comes are, sparking and melting of the terminal, overheating of cables, loose connections, control card damage due to leak voltage, and the specific gravity does not improve on charging, and causing overspilling and spillage, and the battery does not give required backup. Specific gravity does not improve on charging, insufficient charging and sulfation on the terminals. Sometimes, overheating of battery happens. Some customers complain that, twice in a month we have to do top up. That means DM water consumption is very high, and some malfunctioning of the charger. And out of a array of 24 cells or 48 cells, only one or two cells are found weak. Uh, and then we investigate the root cause. So one by one, if I go back to these failure modes again, you as a customer must have also encountered all these failure modes. So if the battery does not give required backup, the probable causes of it is insufficient charging, or a faulty charger, or one or two or three cells inside the battery has weakened, which is not becoming the charge. And remember, all this backup, 70 to 80% of the backup issue can be solved at the site by proper charging, proper top up, and providing proper charging discharging cycle, equalizing charging. With these activities in a series as per the SOP, if conducted, this can be revived on site. Now, if specific gravity does not improve on charging, it does not mean that we have to put water. Okay. Now, there will be a possibility that, during transit or during transportation, the battery has toppled and the electrolyte has been lost. and then nobody has top up the electrolyte, or instead of topping up with the acid, it has been topped up with specific gravity. So if the electrolyte is lost, electrolyte has to be compensated with electrolyte. Okay, in such cases, if the entire battery is not giving backup, then our service team normally leaves the battery to the service station. We remove the complete acid, put in new acid, recharge it as per the SOP, and then we do a 3, 4, C5 backup tests to ensure that the positive plates are fully charged, and they have achieved their capacity, and all sulfation has been lost. So this is some method by which we revive the batteries. Insufficient charging and salvation has to be taken by the at the charger level by the customer, and the charger output and efficiency must be tested. If overheating is happening, there could be two main causes for overheating. One is the external environmental operating condition. If it is extremely hot, okay, then overheating of the battery might also happen. There is no other way other than providing some cooling or respite to the battery. Another possibility could be there is some minor short inside the cell which is causing the battery to overheat. So if overheating happens, the OEM must be informed, and the person will come and diagnose the. In either case, if it is a short is detected, then we shall replace the affected cell, and put the charge the battery again and put it back to operation. DM water consumption also happens because of the above two reasons. One, the temperature is very high. Two, there is an internal short. And three, if the internal resistance of the cell has gone high due to some prolonged storage or anything, and when we try to charge this with a higher current, a lot of heat is generated because of the sulfation, to the extent of I square R. Such will be the evolution of heat, and which in turn will evaporate the water content inside the electrolyte. And malfunctioning of the charger, of course, has to be taken up with the charger cell. One or two cells are found weak. Normally, one or two cells, the pattern is quite common. As I already told you, all cells do not come with, though they are manufactured as per the same standards, all the cells have some tolerances. So in some batteries, some cells might have lesser tolerance, some cells will have more tolerance. So, if the equalizing charge and the charging discharging is not proper, some cells tend to go weaker, and the cells never fail overnight. So these weaker cells, if not detected and repaired over a period of 6 to 8 months, and over subject to continuous cycling operations, this will weaken further, and then at some point of time these cells will stop functioning. So this is called capacity failure intermediately into one or two cells. So the option left with Excite would be to replace these cells if it is under warranty. And if it's not under warranty, then we normally try to revive this on site, take the cells out separately, charge it separately with an external charger, discharge it, and try to revive it. And if the extent of damage is beyond repair, then the customer has to go in for the replacement. So the above failure modes also contribute to the battery does not give required backup. Okay, the conditions under which it might not give required backup is that if the battery has been undersized, the load is too much than as required for the 8 shift operation, and such cases are identified, and the root cause should be identified so that the failures does not occur in future. So we come to an end to the maintenance practices. However, there have been some, development. As I told you, the technology of lead acid battery is, ever since Exide Industries Limited existed over the past 75 years in India. The technology is more or less same. However, to impart efficiency and output and performance, there have been some developments in the lead acid batteries. So one such development is the bolt-on terminal, which has easy replacement and maintenance and replacement. And the forklifts operating over gradients, over some angle, and moving through rough surfaces. The bolt-on terminals are much more efficient and sustain these forces than the weld-on terminal. The weld-on terminal makes the two cells a rigid body, and a rigid body cannot withstand too much of vibrational forces. So the terminal link is the weakest part in both the cells, and this terminal tends to break off when it is subjected to continuous vibration. So such vibrations and such failure modes are overcome by adding the bolt-on connectors. Now we also have a PE coated tray. Now, as I explained you, there might be a leakage current. So leakage current happens, when the electrolyte spillage happens, and these electrolyte spillage normally, if it is a metal tray, what happens is that they form a corrosive path, and they tend to the electrolyte tends to leak, the current tends to leak from the cells through the electrolyte and form a through the corrosive path into the ground. So this causes leakage. However, if it is a p coated tray, it is highly resistant to acid. So there will not be the leakage. Though there will be leakage, it will be very negligible, not significant, and this leakage will also go away if we do regular washing of the cells. So by aesthetics also, these batteries look very nice, and they have a considerably longer time. The trays, because there is no leakage current, there is no loss of electrolyte, there is no leakage current, and there is no corrosion. So the service life is also much more efficient and longer. Now, most of the leakage current and topping up happens during the topping up, because when we do manual top up, first of all, the cells are not equally filled with acid. One cell will have a higher level of electrolyte, one will have a lower level. The higher level will tend to leak during the transit motion of the electrolytes. So to overcome all these difficulties and to have homogeneous distribution of electrolyte and avoid the spillages, we have an automatic watering system. Okay, so to an overhead tank, this instruments, the assembly of this autofill is installed on the surface of the battery, and this also gives an indication whether what is the level of electrolyte, and when it reaches the minimum level of the electrolyte, it can be immediately plugged into an overhead tank, and under the gravity, the electrolyte, the DM water flows and fills all the cells, making it uniform. So it prevents underwatering, overwatering, and we use only battery grade water. So there is no manual intervention also into this. The forklift of operator himself can carry out this activity. So description of autofill. This is the filling plug. You have an inlet and an outlet. Okay. So these plugs are removed where we have the at the center of the cell where we measure the specific gravity. There is a basket that is removed, and these filter cartridges are filled in, and a pipe assembly is made, and automatically flows and fills all the cells uniformly. These are the main quantum components. We have a flow indicator which shows the direction of the flow of the water, and autofill plug is there which controls the level of water. Then we have the hoses, which helps prevent any contamination in the water, external dust surfaces or anything, and transparent enough so that we can see the movement of pump. Then we have the dust cap which prevents the dust. Then the female male connectors and filter cartridge. So hose cap ensures 100% fitment of hosepipe with autofilling. These blocks block the entry of air into the battery system also. So some advantages: no chance of contamination, 20% increase in battery life if we use autofill system, and makes battery virtually maintenance free. So an add-on to this is the electrolyte level indicator. So the electrolyte level indicator blinks whenever the electrolyte level goes below the minimum level, and gives an information to operator to fulfill the requirement of DM water in the battery. I thank you all for your time, and that's all from my side. I thank Godrej team also for this session. Now we may move on to the question answer. Yeah, over to you, Dikshit.
Right, right. First of all, I wish to thank you for this insightful session, sir. Such a simple thing means, we from an outsider's perspective or a layman's perspective, it is just a battery and a charger. Okay, it's such a simple thing, day-to-day
Yes.
thing that we put phone on charger. But I who could have never imagined that the process and the components are so complex. Okay, and let me tell you, we are past 14 minutes out of our scheduled time. Okay, and not a single participant attendee have dropped out of this, and even we didn't, feel to interrupt you looking at the knowledge that you are pouring in, and
Thank you.
we
Thank you.
really
It's my honor.
yeah
It's my
we
honor. Thank you.
yeah we really appreciate that, sir. And looking at the questions, we'll take very one or two questions. You have explained everything you have explained, but we'll take one or two questions looking at the time. Okay, so
Yeah.
sir, there's one question from cold store. Sir, what are the best practices for batteries operating in equipment in cold store and ante rooms, the
Okay.
equipment that I used in cold storages? Are there
Okay.
anything
So
specific? Yeah.
no, see, the normally the lead acid batteries are, designed to operate from a temperature range of -5 degree to 50 degree.
Hmm, 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 hmm.
Okay, so the cold storage, we do not need to take nothing like the performance of the battery or anything will not be affected much as far as the
Correct.
motive traction battery is concerned. However, if the batteries are stationed inside the cold storage room for a prolonged
Hmm,
period of time, either ideally or in operational condition, as far
hmm,
as the battery is getting operated, nothing much will happen. But if it is allowed to stay inside the cold storage for a longer period of time, then during the charging period, the charging procedure needs to be altered a little bit. The charging current, the recommended charging current, and the duration of the charging current, and all these things, and
hmm,
the
hmm.
equalizing charge period, all these things needs to be altered a little bit. So we as such don't have any theory for this. I mean, a standard practice for this. But if we are given the conditions under which the temperature and the period of storage and the period of operation, then we can design a maintenance practice for such kind of applications. So certainly, if it is between 5 degree to 50 degree, -5 degree to 50 degree, nothing will happen. It should work
Correct.
normally.
Correct.
Hmm?
Great. Great. And I'll go for second question, sir. So
Yes.
there are some areas in the country wherein power cuts are very much frequent. Okay, though
Yes.
those are in industrial area. So would that affect if our equipment isn't charging? Okay. So will that affect it gravely, or how is it? I mean,
Yes, yes, it will affect. See,
it will
I'll
affect.
explain you. Now,
Hmm,
when we talk about charging, what actually
hmm,
we are doing is that, 15% AH
hmm,
capacity. So again, I take an example of 100 ampere because, that's easy to understand.
hmm,
So
hmm,
if I charge, with 15% of 100 AH will be 15 ampere.
hmm,
Right. So 15 ampere, I have, whenever I discharge the fundamental is that if I discharge the battery to 20% or 80% DOD, then I have to
hmm,
recharge the battery back to 150% because there will also be some losses of heat, some losses for the cells to equalize and adjust, and to the float voltages there will be losses. So to compensate these losses, and we say that when we charge it to 150%, anything
hmm.
between 100 to 150% it's fully charged. Now, if I
Okay.
consistently charge my battery with 15 ampere for 10 hours, I'm inputting 115 50 Ah. Okay, which
Correct.
brings my battery to the state of fully charged. That means the specific gravity will go to 1.280, the voltage will come to 2.65 and then stabilize to 2.17, 2.20. Okay,
Correct.
so this is the condition. Now imagine I have a power cut of 2 to 3 hours in between. Okay, what
Hmm,
have I lost? I have lost 3 hours. I have left with 7 hours only, but I will be inputting 7 into 15.
hmm.
Okay.
Okay.
So that much AH only I'll be inputting into the battery, which will bring my specific gravity
105.
to maybe, yeah. So 105, which will bring my specific gravity to maybe 1.25 or 1.26. Okay. And it will be in a state of intermediate charge, not fully charged. So
Uh,
once or twice this power cut during the charging period is okay. If we are not able to compensate it with DG, and if we know that what has been the duration of power cut, we can extend the charging. One is that we can extend the charging period in the next day, 3 or 4 hours, or else
mhm,
if they are under production, they allow the battery to operate in that. They might not get 10 or 12 hours of backup. They might get 1 or 2 hours backup less. But in the
Correct.
next charging cycle, they must ensure that the battery is 100% charged back to its 100% capacity again.
Great, 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 sir. The questions are still pouring on. We'll take it
Yeah. I mean,
off.
we can. I don't know about your timeline, but I've got some more time. We can take if there are any important questions. Yeah.
Okay, okay. I'll take one, the
Yeah.
last one. Okay,
Yeah.
wait a second. How frequently should one conduct routine maintenance checks on lead acid batteries in MHEs?
See, routine checks, like I told you, the checks should be done on every charge discharge cycle. So I
Hmm,
know it is not possible, in a production capacity running with beyond 100% capacity, the people will not have
correct.
time to check the specific gravity, record
Hmm,
it and note it and all. So at
correct.
least once in a week, one day will be off, like,
Hmm, hmm,
though it will be 24 by 7. Okay,
hmm,
at least one shift will be off for the batteries. So when
correct.
that one shift is off and put the batteries on charge and equalizing mode or whatever, and when you resume the next shift, at least during that shift, you must note the voltage and specific gravity.
Oh,
Okay, so that this record is important to analyze, make it to design a trend. Are there
correct.
any upcoming threats? So
Hmm,
looking at
hmm,
the
hmm.
fall in voltage on specific gravity, we can easily identify, because no battery will fail overnight. Unlike any mechanical or electrical component, the chemical component does not fail overnight.
Correct.
Okay, in
It takes
mechanical,
time.
you might have bearing seizure happening, immediately. You never no one know how, why that bearing has seized, got that bearing has
Yes.
seized, or why that relay has gone off, for what reason.
Correct. Correct.
But
Correct.
in battery, it never happens. It happens over a period of time. So this trend analysis will definitely help us prevent breakdowns in future.
Batteries give you time.
Yes, it gives us time. It gives us a lot of time.
Yes, yes, yes. So without
Yes.
before bidding you bye, sir, I request all our attendees to fill in the feedback form. This would help us to get more of suggestions. Means individuals like
One more.
suggestions. Yeah.
Yeah, Darshit, I mean, my number
Mm.
is there. I mean, you can share my email ID and my number with the participants. And,
Yes, yes, yes.
unanswered questions may they can directly call me or mail me.
Correct,
Okay,
correct.
and if they are from different industry and they want a training session, we
Mm.
also provide training session, and there is no cost associated to that.
Yes,
So,
yes, yes. That's always
so
there as we are
they can get in
we
touch with me. There is no problem through you,
correct, correct.
or
And we too are
yeah,
associated with Exide. So that's
yeah.
never a problem and never should be in the future. And yes, sir, as this is the last session of our knowledge series for this year. Okay, so we wish you and everyone here a happy new year